In this lesson, I'm going to cover another important C# concept that we can immediately apply to our game project, and that is the topic of arrays, as well as the closely related concept of looping statements, which are also called iteration statements or just loops. So to better understand arrays, we can kind of recycle a previous concept of containment that we looked at earlier, but use it in a bit of a different way. So remember when I dragged out those boxes and showed all of these containment structures? You know, our squiggly brackets, they're kind of like these containers within containers. Well, the concept is pretty much the same with arrays. The simplest kind of array is just a single box that in turn it contains a bunch of boxes. Just like why you'd have boxes within other boxes in the real world. You would do this whenever you want to logically group things together and yet all still be reachable from within a single reference point, right? That broader single box that all those boxes are inside of. So now I'll show you how to create an ordinary array box in script. So first in our tests folder, create a script called arrays and loops, and then we'll attach it. Arrays and loops, and we'll attach it as usual to our test game object. Open it up. And, well, we only really need start, so in start, this is how you declare an array. So we want an array of integers. After int, use those left bracket and right bracket. It sort of looks like a box, actually, beside the type. So that's an array of ints. That's what we're saying here. We're declaring that as the type here. And we'll call this, we'll label this as array example. That's the name or identifier. And then we'll use the new keyword and then again reference the type with this box. And then inside this box, we declare how many sub boxes, how many boxes within this greater array box we have. So we're going to set it to 5. One thing you should know right away is this is fixed, the declared amount of sub boxes that you have. Once you set it here, it's not really easy to change with arrays. So now that we have 5 boxes, each of these sub boxes can each hold a single integer value. Now each of these inner boxes have preset labels called indexes or indexers or indices, whatever you prefer, and the boxes are labeled starting from 0. So we can stuff into these boxes their individual integer values by referencing the indexes as follows. So reference the name and then the index. So the first box starting at 0, we'll put in the value 22, and the second box, see, arrays are 0 based, so it's kind of awkward. It's one of the most challenging things to remember with arrays, that they start from 0. So the first item is 0 and the second item is 1. Just something you have to get used to, not a big deal. Actually can cause errors though in compilation if you make a mistake, as it's almost certain you will with having an index out of range. We'll probably deal with that at some point. And 36 for this. Two. And for the fifth one, give it 8. Now, when you want to reference these sub boxes in whatever way, you sort of open up the box and get that number by referencing the array through its index. So, for example, do something like this. We'll output it to the debug log. Array example. And now let's grab the third box. Right? See, that's what I'm saying. You got to get used to that. You're probably thinking that's the second box. No, it's the third one. We're going to expect it to output that. So let's run it just to make sure it's working. There you go, 36. Okay, that's all really great and all, but you must be wondering, why are arrays so useful? Why not just make 5 individual integer variables and name them something like example 1, example 2, example 3, and so on, and then just treat that as your sort of pseudo-grouped collection of values? Well, in this simple scenario that I showed you here, that would probably work just fine. But where arrays really show their power is when combined with iteration statements or loops, right? So there are a few different types of loops in C#, but to my mind, the most foundational loop is the for loop, as it has built into it much of what you would need often when iterating through collections such as arrays. So you have a counter, a conditional evaluation that continues a loop until it becomes false. So it's sort of like a built-in if statement, and an incrementing calculation for the counter. So to set up a for loop, I'm going to show you a cool thing in Visual Studio called code snippets. Code snippets are just a simplified shortcut of sorts for establishing a common code template. So for example, the code snippet for loop is for tab, right? And I did that kind of fast, so I'll actually show you that the code snippet shows up in IntelliSense, and there's a bunch of code snippets for lots of common code elements. So there's a code snippet for the for, there's other stuff here. You'll see the Foreach later. So when you use the code snippet, it sort of sets up a preset, like a template for what makes up a typical for loop. So as I mentioned earlier, you have the counter, which is initialized here to 0. Typically it is, though it doesn't have to be. And then if the counter is less than, and here it gives you sort of a random variable that has no meaning right now, it just reminds you have to put in whatever the uppermost limit number you want to reference is. And also you have the way that the counter increments. So with this for loop, I'll show you how to loop through our array to output all of its values. So we have 5 individual values in our array. So I can write in if our counter is less than 5, right? But this isn't always going to work because sometimes you don't know what the size of the array is. In this case we do, but when you don't, you can reference a really handy property of arrays built in that's called length. And just to mouse over here, it says gets the integer that represents the total number of elements in all the dimensions of the array. So that will return 5. We know that that's what that will return. And then simply do this. Debug log. And then what we can do is reference that counter right there. So we know that the way this works is it's sort of like an if statement that just loops. So it first checks the condition if the counter is less than 5, so it starts off at 0. If that's the case, then do this. We know that this is going to first print out 0, or the first index array, this one, right? It starts at 0, that's why that's important. And then it loops back around until this evaluates false, which it will once it reaches 5. So let's just run this so you can see how it outputs. It's going to output to the console. Actually, comment this out first. There you go, it just outputs in order each element or each item in the array. So let's put a little comment here. I'm going to mess around with this and show you how you can go through different variations on these loop conditions. And so we'll put a comment here that says increments through the array. And we'll comment that out for now. Actually, I'll copy and paste it, make it a little bit quicker. and make the changes to it. So we'll want to take this and place it here. So it starts off at the uppermost limit in the array, which will be 4, right? And now, see, this is going to return 5, right? Because we have 5 items, right? But if we start by referencing the 5th element, this will return 5, so it will reference a 5th element that doesn't exist. So what we'll want to do is just take that and minus 1 from that, so that returns 4, right? And if I is less than, actually greater than or equal to 0, so as long as it's not below 0, because again, there's no array element or item below 0, that's just not possible, we'll actually decrement that counter. So now we'll loop through the array in reverse, essentially. So I'll actually put the comment there for that. See? There. Goes in reverse. Let's look at some more versatility with array looping through arrays. Comment this out. Now what we can do is decrement and output only even index items in the array. So let's do this. Copy this. Comment. Here we'll put a little conditional. Wrap around the debug log in a conditional. So if I use the modulo operator, if it returns 0, so in other words 2, 4, 6, 8, and so on, then only output those, right? So the second index, fourth index, and so on. Try to anticipate what it's going to spit out. 8, 36, 22. In reverse order, right? So, right, and 0 also. All right, a little variation on that. If you want to output only odd values in the array itself, so why don't we do that as well? And this time we'll actually check the value in this conditional. So the value that's stored in this actual box. So is it an odd number? That's how we do that. So the way you look at this is the 2 goes into 3 and it leaves a remainder of 1, right? Or 2 goes into 5 twice and leaves a remainder of 1. 2 goes into 7 3 times, leaves a remainder of 1. So that's how this works. So that's how we get the odd values only. All right, we only have one odd value, I guess. All right, these are all even, except for 33. All right, so that's a basic for loop and just a taste of what you can do with for loop and typical kind of for loop usages. Now, in a game scenario, this might have a multitude of uses. And the only reason you maybe don't see this kind of loop much in Unity is because, if you recall, we already have a game loop, predominantly through the update method, which Unity calls on every frame, creating the loop state, right? So what that means is, if you have a loop occurring within the game loop, the entire loop executes on a single frame, right? So I can show you this by putting in the update method instead of start, and you'll see what I mean. What's it going to output? On every frame, it's just going to go through that loop and output on every frame 33. Right? That's not what we want in many gameplay scenarios. So there is a solution for this in Unity with something called coroutines. Coroutines can be seen as something kind of like another update method that runs beside the normal one. Except in a coroutine, you can sort of pause the loop execution in, say, a for loop on each frame. And so then it will continue from the previous iteration point on the next frame. But we'll get into that a little bit more down the line. Now, we can actually make use of loops and arrays as is, just all executing on a single frame. So there are many actual uses of this in many different cases. So one example that we'll be looking at right now is we had a problem with the sprite renderer in the teleport fading algorithm. Now, it just faded out the current sprite renderer for the cheesehead game object, but ignored the children game objects, right? What we want to do is fade out the parent along with the children. So to solve that, we can simply use the Unity method called getComponentsInChildren instead of just getComponent, and that method will return an array of sprite renderers. So all of them, our parent game object as well as its children sprite renderers. And then what we can do is we can loop through each of those sprite renderers and apply the same lerp process on each frame for each renderer. So we can do that like this. First, actually, remember to deselect this so it doesn't get in our way. And go to cube animate right here. That's where we had this previous call to get component. So it only grabbed the component for the main sprite renderer, but not the children. So we can fix that by doing this. Okay, what we should do is actually put this in a method called teleport fade. And I'll just put this in, don't have to make it private, but I will. Been doing that with our private methods that we've been creating. So keep up with consistency. So I'll put in the previous code in its own method called cube fade, just for posterity, not for not because we're going to end up using it, right? Just so you remember that it's there. Contrast it with this other this solution that we're going to create here to our problem of fading. Just so I don't forget, right away I'll call teleport fade here in the update. And here in teleport fade, what I'll do is this. I'll use get component in children, and it's a generic method, and we'll want the sprite renderer returned for each game object, the parent and the children's sprite renderers. And we'll take that return value and put it into a temporary sprite renderer. See here, I'll just show you. This method returns, sorry, I used the wrong method, and actually this is illustrative. So remember, you can have big problems in code with just a single character missing. Get components plural in children, and that returns a array of sprite render, as you see there with the little box. So we'll return that to a sprite renderer array, a local variable that holds an array of sprite renderers, cube renderers, that's what we'll call it. And then we'll use a little for loop here. And so we'll start at 0. and then we'll reference cube renderers.length property, and we'll want to increment one at a time through each element in the array. And for each element, we'll want to sort of repeat the same process as we had before. So the color, we'll set that to the particular sprite renderer that we're dealing with at any given moment through this loop. Grab its color property, and well, you just copy and paste the previous condition here. And then now we'll want to just assign it that color back to the actual sprite renderer that we're grabbing, the actual component. And we do that by referencing its index in the array, just like that. Right? So let's run this now, and we expect all of the game objects that are part of cube to fade now, right? When we engage a teleport. So let's see. Yep, there we go. Let's even see if, and let's see actually if the teeth renderer, if the teeth sprite renderer is included. We expect it to. I'll have to grab a power up, so bear with me here so I have a little bit more time. Yep, there we go. If you notice that I didn't have a detected collision, it's because we have to have the eye sphere enemy overlap our cube completely, just so the game's not too challenging. All right, well, this works fine, but actually there's an even easier type of loop that is in a lot of ways a lot easier to read that would be great for this task, called Foreach, the Foreach loop, which operates in pretty much the exact same way as the for loop, except it has an implicit fixed incrementing counter. So what it does is it just iterates through the entire array, one after the other, incrementing one at a time until it runs out of items. So we can just change this to a for each loop. Actually, let's call this teleport fade 4, and make a new method. So we're not going to use these anymore. I'm just going to let them hang around so you can reference them and look at them. I'm going to call this for each and call that here teleport fade for each. All right. So this is how we're going to do this. Let me just grab the stuff that doesn't really change. Temporary color conditional aspect. And now, well, we'll start with the same thing with grabbing the components, the sprite renderer components, and storing them to a temporary array. Get components. This time I'll remember the plural version. Components and children. And then here I'll use a for each loop. I'll use the code snippet. So var item in collection, that's the sort of templated form here for each. I'll briefly go into this in a minute. So what we're going to do here is, because it has a fixed incrementing sort of implicit counter, what we use to reference the particular array item, whether it's the first one, second one, third one, or whatever, is we use a temporary variable that's local to the for each method itself to store that particular item in the array. And that we do that here. So we have a collection or a array of cube renderers. So reference that there. So for each item in the cube renderers, it's of type sprite renderer, right? Each item is a sprite renderer in the array of sprite renderer. And we can call it item, but I'm just going to call it local to this for each loop renderer. And, oops. Let's again grab this stuff here. And we'll say color equals renderer.color. And then assign to the actual sprite renderer component right, because each temporary variable here will act as a reference for that particular sprite renderer in the array. So that will be the actual, it'll be referring to the actual sprite renderer component for each game object. And now let's run that. It should run the same way, but it'll look a little bit nicer in code. Yep, runs the same way. So yeah, the most important thing to understand about this for each loop is this temporary variable that's an individual sprite renderer within the broader box of sprite renderers, the array, right? So at the very first time this loops through, this renderer will be the first item in the array, right? The 0 index, in other words. And the second time it will be the first index, and so on. So that's how that works. That's how you should be looking at it. All right, so to summarize the key points, arrays are immutable. That is to say, once the type they store is declared, that's it. That's all that array will hold. So either just strings or just ints or just wizards or sprite renderers, whatever. And also their size is immutable. The amount of individual boxes within that main array box. And arrays are fine for grouping similar items, but their strength is in putting them through an organized process to each item. So whenever you need to produce or perform a process on a bunch of items, right? An array is usually a good place to start, and then use an iteration statement or loop to do that task, right? So a for loop uses a counter that you can reference in the loop, and you can use that counter to make for interesting variations, or you can use the easiest kind of loop in the case of arrays, the fixed incrementing Foreach, which works with things that are more broadly called actually collections, not just arrays. So that's arrays, lists, enumerables. We'll see some of these in action later on. So those are collections. But really we'll be able to do just about everything we need with just basic arrays. They're the most basic and foundational collection type object in C#. So at least for a while, that's all we'll be dealing with. You'll often also see in C# a generic type called list, and then those angled brackets because it's generic. And in those angled brackets, you can determine the type that it stores, right? So either ints or wizards or sprite renders or whatever. And this has some benefits over arrays. In particular, lists can be easily resized, have elements added or removed as well. But if you don't need those kinds of functions, just stick with ordinary arrays, right? Because otherwise lists are just a little bit of extra cognitive load to deal with, at least at this point. So great job if you've been following along and writing all this on your end, and I'll see you in the next video.